Hi everyone, and welcome to this math tutorial or math lesson specifically on the number system. And during this very short but very important lesson, we'll be having a look at the number system and what kind of numbers and what kind of sets of numbers we get within mathematics. These sets are not the entire full set of numbers that we can find, but it is the system that is the most important for grade 8, 9, 10, 11, and 12. Grade 8 and 9 need to be able to identify the type of number by just looking at them, and then the grade 10s, 11s, and 12s usually need to define some numbers when they write down an answer. If you find this video helpful, please remember to like and comment and tell me if you have any problems so that I can offer another explanation. I'm always willing to help. And don't forget to subscribe to my channel, as this is a new channel. I would like to see it grow. Let's jump in. So within the number system, we get a big domain called the real numbers. And this is where most of our numbers are going to fall under. And within that, the biggest part will be made out of the rational numbers. And the rational numbers include natural numbers, counting numbers, integers. It also includes fractions, decimal fractions, as well as common fractions. Outside of this, but still in the real number domain, we'll get the irrational numbers, and then completely outside of this, we'll get the non-real numbers. Let's go and have a look at what each of these systems means and which numbers are included. So for the natural numbers, we represent it by the letter n. And this includes all positive whole numbers, 1, 2, 3, 4, 5, etc. It can be odd or even numbers. It can even be prime numbers or composite numbers, or it can be squares and cubes. This is not limited to only these groups, but these are the most common we'll get. Then we'll get our counting numbers. Our counting numbers are represented with an N and an O. And this just literally means that we add 0. 0, 1, 2, 3, 4, and so on. So we just add 0. For integers, represented by Z, it includes all negative numbers. -3, -2, -1, 0, 1, 2, 3, etc. So let's go represent this on a number line to see how it fits in visually. Let's draw a number line, and then let's start by adding our positive whole numbers first. And we know these numbers are our natural numbers. If we add 0, we now include our counting numbers, 0, 1, 2, 3, etc. And if we go ahead and add in our negative numbers, this all will form the integers. When we talk about fractions, we get two types, decimal fractions and common fractions. Now, decimal fractions are a numerical representation, 0.3 or -2.18 or 0.6, while our common fractions are represented by means of a numerator and denominator, -1/2 or -1/2, 5/2 or -1 1/3. Now, fractions can be proper or true, improper or false, or they can be mixed numbers. Where do they fit in? Well, anywhere between the whole numbers. For example, -1.4, decimal fraction, or 3/4 or 3/4, proper fraction. Rational numbers. Let's have a look at what rational numbers are. First, it is represented by Q. And this is any number that can be written as a fraction where the denominator does not equal 0. So if we have a fraction and we have an integer and an integer, numerator, denominator, the denominator may not equal to 0. For irrational numbers, we add a little comma to our q. And this is any number that can only be written in number form and never as a fraction. These numbers usually is infinite, non-repeating decimal numbers. What does that mean? Well, if I have pi, pi is never repeating the same decimals as a pattern, or for example 2,719,832 without any repeats, etc. going on, then this is considered to be an irrational number. Finally, we get non-real numbers, and non-real numbers are numbers that cannot be represented on the number line. And this is, for example, the negative square root of 25, because a negative number underneath a square root can never be represented on a number line as a real number. A non-real number, yes, an imaginary number, most definitely, but this is definitely non-real. So here's a typical example of a question that can be asked in a test, and you'll notice that you'll get a table and you have numbers and you need to identify whether it's a counting number, natural number, etc. Let's have a look at that first one. The first one is 2 over 3, 2/3. We know that's a proper fraction. A fraction is not a whole number, so it won't be a natural number, it won't be a counting number, it won't be an integer, but it will be rational, definitely not irrational. 1,25, this is a decimal fraction, but it's also a mixed number, meaning that we have, again, not natural, not counting, not integer, rational, not irrational. The square root of 16, the square root of 16 can be simplified to 4. And 4, we know, is a natural number, counting number, integer. It is rational and not irrational. 0,25, the 5 repeats. Again, this is a decimal fraction, so not natural, not counting, not integer, rational, not irrational. -5. -5 is a whole number, but it is negative, so it's not a natural number, it's not a counting number. It is, however, an integer, it is rational, and not irrational. Pi we know is very unique, since the decimal is infinite and non-repeating, meaning that we will have not natural, not counting, not integer, not rational, but irrational. The same for the square root of 18. When we input that into our calculator, we'll notice that it is also an infinite, non-repeating decimal fraction, meaning that it's not natural, not a counting number, not an integer, not rational, but irrational. The number 0 is most definitely a whole number, but it's not a natural number. It is, however, a counting number. Integer, rational, and not irrational. 0,548 with the dots. The dots tell us that this is infinite and non-repeating. So we have, again, not natural, not counting, not an integer, not rational, but irrational. Finally, we have 25 over 5, an improper fraction. If we simplify that, we are going to get to 5. 5, we know, is positive, whole number. It is a natural number, a counting number, an integer. It is rational, and not irrational. And there you have it. A few numbers to show how we use the number system to identify what kind of number we are using. Thanks so much for watching, and I hope this tutorial will help you better understand the number system.